In our previous videos, we have made a chemistry game where we can drag molecules into this image sprite and then save them with certain names. So in this video, we are going to actually make the game check our answers, check our results. I have created two molecules already, water, and if you take a look when I press guess, it's going to show hydrogen, which I've misspelled, but nonetheless, it'll show two hydrogens and an oxygen. Show new is going to pick a new item from our TinyDB from our database. And I've already also saved carbon dioxide. So you see when I click guess, it's going to say carbon, and then carbon again, and then oxygen. And so what we want to do in this video is we want to allow the user to drag molecules in that match this label up here. In other words, if I see carbon dioxide and I'm a user, I want to be able to drag those two elements in, plus an oxygen, and then hit guess and see if my guess is correct. So we want to give some outputs here. We want to say, yes, you are correct if the guess is correct. If the guess is wrong, then we want to say how it's wrong. So we're going to leverage some work that we've already done. The button guess event handler is going to read our molecule from the database. And in our database, in our TinyDB database, we have the molecule name set as a tag. Okay, and the value is a list of elements that make up that molecule. So just a reminder on what we've done before. We're initializing a local variable called red molecule, and we're initializing that by going to our database called molecule. Just so you remember here, it's called molecule. And what we're doing is we're getting the list of elements that is associated with this variable called global guess molecule. Now, where did we populate guess molecule? If we take a look at the button handler for, let me find it here. Sorry, it's off. I think it's off screen a little bit. And actually, it's just down here on our blocks view. If we take a look at get this out of the way, the button handler for show new, what it's doing is it's going to our database, again, the database called molecule. It's picking a random item from all of the tags. Remember, a tag is a unique identifier. It's kind of like a key. So we're picking a random tag, and we're setting that to the inside this variable called guess molecule. Additionally, we're taking that molecule and we're making that the label text on our app right up here. So right up here, carbon dioxide. So when I hit show new, it's going to pick a random item from that list. It might be carbon dioxide, might be something else like water in this case. It's storing that in the variable global guess molecule, and it's also populating this thing called answer key. So those are some things that we're doing in the show new button. Okay, so I'm going to go back to our handler. Where'd it go? Our guess handler. And this is where we are iterating over the list of correct elements that make up this molecule. At the moment, we're showing them in a notification. We don't want to do that. We want to have the user actually guess. Now, here's one area where I wish we had another collection that's available in Java, and that's a hash map. A hash map is just like TinyDB, except a hash map is in memory. It's not persistent. In other words, a hash map allows us to store tags and values. I would like to have a new hash map that stores the number of elements in the molecule, but anyway, that unfortunately just isn't available to us in App Inventor. We just have a simple list. So what I need to do is I need to make variables for each of the four elements that we have on the screen now. So oxygen, hydrogen, nitrogen, and carbon. I need to make a variable for each of those. That's why I wish I had a hash map, because I could have just one big hash map that has all the elements, and then if we add more elements in the future, then we don't need to add any more variables. But anyway, that's not a big deal. So what I'm going to do is these can be local variables. I'm going to go up to the variables tab, and I'm going to get blocks for three new molecules, or three new variables. We'll just make them hydrogen. Whoops. Oops, sorry. Let me try that one more time. Hydrogen. Okay. I'm going to grab another variable block, and I'm going to make another one. We're going to nest these so we can have access to them all at once. Carbon. Okay. One more variable block, or actually two more. We're going to make one for oxygen. And once again misspelled, oxygen. And then one more variable block. Okay, final one's going to be carbon. And you see how the trick is that as it is now, we would have to make one variable for every element in the periodic table. That's not very flexible. That's a limitation that we'll have to deal with at the moment. But for just 4 elements, not a big deal. Now, what's going to be in these variables, though? Well, it's going to be a counter. And the counter is going to say, for the molecule that we're currently displaying and we're asking the user to guess, we want to count the number of hydrogens, the number of carbons, the number of oxygens, and the number of, oh, I have carbon twice, don't I? Number of nitrogens. So we're going to keep a counter of each of these, the correct answer, and then what we're going to do is when we look at what the user gave, we're going to see how that compares to our counter of the correct answer. So I need to initialize all these to the number 0. So I'm going to grab the number 0, copy, and we'll paste 4 times, just make that a bit easier, and then we'll plug these in. So we're starting with the assumption that we have 0 items in our counter. Okay, now time to reuse some things that we've made earlier. We already know that we can iterate over the answer key, and we know we can show the answers one at a time. We've already proven that because if we take a look, I have water, and if I choose guess, it's iterating over the correct answer, not what the user said, but what the correct answer is. Hydrogen, hydrogen, oxygen. Okay, that iteration you see is what's handled by this loop right here. So I need to take this loop, move it up inside of my local variables. Let me grab this over just a little bit so we can try to get it to fit on one screen. Okay, that looks good. Now, instead of adding a notification, I'm going to increment one of these counters. That is going to require an if test. So let's pull the notifier out for the moment. And let's go to control, and we're going to need to put together a fairly complex if test. Okay, drop. Okay, and the variable answered items is our iteration variable. So it means every time we loop, the next element will be in this thing called answered items. So hydrogen, the first loop, hydrogen, the second loop, oxygen, the third, if we're looking at water, or carbon, the first, carbon, the second, oxygen, the third, if we're looking at carbon dioxide. So that's where I need to make this if test increment or add 1 to each of these values each time it encounters another element. And I can tell this is going to be a big block. I need to make a little more room for myself here. So let me move a few things out of the way here. There we go. That we're probably going to end up deleting, to be honest with you. Now, because there are 4 elements that could be in this answered items variable, I'm going to need 4 if tests. But it would be inefficient to try to create 4 separate if tests. Instead, what I'm going to do is start with 1 if test, and then we're going to add 3 else ifs. Okay? Okay, so essentially, these are 4 different if tests tied together. What we're going to say here now is we're going to do a comparison. Okay? A simple compare text will be fine. So compare text. Okay, what are we comparing? In each case, we're going to be comparing this answered items. Remember, answered items is the current element that we're iterating over. So again, carbon, carbon, oxygen for carbon dioxide in that order. Okay. So each one of these is going to be comparing this thing called answered items. So I'm going to clone this comparison 4 times. Whoops. Okay, there we go. And again, I'm just going to try and make a little bit of room here. Okay, now we need to compare them. So let's see. We need to compare them to the names that we're storing into our database. And let's see what those names are. I know I misspelled hydrogen, so I want to make sure I'm consistent here. Of course, the best thing to do is to fix hydrogen. It looks like that's good. Oh, I see. HYRD. Okay, so hydrogen. Okay, we're going to compare 1 to hydrogen while it is misspelled, so we'll fix that in a future iteration, but I already have the emulator up, so I'm going to leave it where it is. Okay, and I'm going to paste. Nope, that's not what I wanted, sorry. I go back up to my hydrogen. Okay, I'm going to grab this guy, Control C, Control V, going to give me another hydrogen, just like the one I'm using up there. Okay, drag him down. And, whoops, almost. Okay, grab our hydrogen and plug them in here. Okay, if the answered element is hydrogen, then what do we need to do? We need to add 1 to our hydrogen count. So I'm going to say set hydrogen to, this is going to be in our then part. Remember, this then part will only execute if this if part evaluates to true, if these two things are equal. So set hydrogen to, now here's the trick, I need to get the current value of hydrogen and add 1. So I'm going to need to get a little bit of math here. We're going to need one of these kind of summation things. Drag him. Okay, so get hydrogen plus what? Plus 1. Okay, we'll get one of our numerical constants here. So you see, if it's a hydrogen, we're adding 1 to the number of hydrogens that make up this composition. We're adding 1 in memory. Okay. I'm going to repeat this for each of our elements. So I'll take this block here, and easy enough to change this around. Control C, Control V. Let's make the next one, instead of hydrogen, let's make it our friend, how about carbon? Okay, so I can easily pick carbon from the list, and then we'll say get carbon plus 1. Okay, instead of comparing it to hydrogen, we need to naturally compare it to carbon. Almost. Okay. And I'll pause the video as I fill out the rest of this test. And with the magic of our video and the pause button, we see that I've now completed the if test. So if it's hydrogen, add 1 to hydrogen. If it's carbon, add 1 to carbon. If it's oxygen, add 1 to oxygen. If it's nitrogen, add 1 to nitrogen. Now this feels kind of redundant, doesn't it? Because I'm pulling these elements out of the database. And then I'm storing them into local variables when I already have them stored in the database, right? Well, that's true, but I do want to have them in memory, because the next thing I'm going to do is I'm going to see what the user entered into the image sprite, the little molecule box, and then I'm going to go in the other direction. I'm going to decrease by 1 each of these elements for each element the user put into the box. So we're going to need to iterate again, and I realize this is going to turn into an enormous block here. But what I need to do is I need another for each. Okay, for each item in list, we'll just kind of put this right down here. We'll put it next to our for each that's reading from the database. Okay, now what list are we pulling from? Well, if you remember, every time we add an item to this image sprite, it adds to a list. And let's remember how that works. It's a collided event, and I know it's one we set up several. So if hydrogen collides with our molecule box, then we're going to add an item to the list called global molecules. So don't confuse this with what's in the database. This list is what we drag into the box, where the list we get from the database is from a previously saved molecule. So we're comparing what's in the box with that previously saved molecule. We know what's in the box is in this variable called global molecules. So now let's iterate over that thing called global molecules. Okay, actually, let's see if I can probably easier get, okay, global molecules. There we go. Okay, so we're iterating over the user's guess. Now, to save a bit of time, I'm going to try and borrow this if block that we've already created, because that was a lot of work, wasn't it? So I'm going to just Control C. Same logic applies, we're just looking at a different list. Control V, take that block, and drop it in there. Okay, you know what I wonder is if it would let me do plus minus 1. I guess it will. Okay, so I say I could switch all of these out to be a different math operator. I could use the minus, but effectively plus a negative number is going to work the same. Okay, so we increase the number when we read the answer key from the database, and we decrease the number when we see what the user has entered into the list. Okay, now what we need to do is we need to say, okay, a right answer should give us all variables at 0. So in other words, For water, we're going to have 2 hydrogens and 1 oxygen, so we're going to have 2 here and 3 here when this loop is done, read from the database. Then when we compare our answer, we're going to subtract 2 from hydrogen, subtract 1 from oxygen. Those should balance out to 0, and in that case, we have the correct answer. Looks like I have one more thing I need to fix here. I need to change this variable to our iteration variable, which is called item. So just a moment as I fix that. Okay. And we'll save. Okay, next thing we need to do is we need to see if our what our counts are, which ones are 0, which ones are greater than 0. So I'm going to go to I'm going to grab an if then, and we'll do an if then else. I'm going to drag this kind of like as an answer, so we'll put this down here. I'm going to say if, and then we'll say we need to do a mathematical comparison. So we'll say if, and let's see if I can grab my nitrogen. Or let's say, well, I'll tell you what, all of our compounds so far are carbon, hydrogen, oxygen. I'm not going to worry about nitrogen at the moment, just to kind of simplify the video. So we're going to say if our oxygen equals 0, then we can grab our notifier and say you have the correct amount of oxygen. So notifier, and we'll say probably show alert. Yeah, that'll work. Actually, you know what? I think of a better idea. We could just kind of build up a string. So if oxygen is equal to 0, then we can say you have enough oxygen. On the other hand, we'll do an else if, and this time we're going to do a similar test. I'm going to say else if oxygen is greater than 0. That means that we have more oxygens in the answer key than the user has provided. That means the user is short in oxygen. Okay, let's add one more else if. And let's cover the case where oxygen is less than 0. That means we have a negative number and the user has added too many oxygens. So I'm going to go ahead and say less than 0. Okay, and what I'm going to do is, we could probably just, I'll tell you what, I'm going to duplicate this block. And instead of oxygen, we're going to do the same thing for carbons. So duplicate the block, and this time I'll just make each of them carbon. Okay, and again, we're not going to worry about nitrogen at the moment, but I will do one more for hydrogen. Okay, really long block. I know this one's getting really crazy. This one's going to be first on the list for refactoring when we get to that. So hydrogen and hydrogen. Okay. Good. So now we just need to raise some alerts. What I can do, I'm going to grab a new variable, one more variable, and we're going to make it a local. And we're going to say result. We're going to say like this is our result message. Okay. And we are going to start this off as an empty string. Okay. Well, actually, we'll put something in it. We'll put no, then we'll start it as empty string. What I do want to do, though, is I want to nest each of these if tests inside of this. So what I can do is I can assemble this result message. I'll grab variables. We'll say set, and then we'll say result message 2. And then remember our trick here, get result message. We need to do a bit of concatenation. So join whatever's in the existing result message. Okay. With one more text string, which is oxygens are correct. Okay, comma, space. Okay, now I'm going to take this block and we're going to drop it down here. We know if the number is greater than 0, we'll say you don't have enough oxygen. Okay, and finally, we know if oxygen is less than 0, the user added too much oxygen. So we'll duplicate this once again, and we will say you have added too much oxygen. Okay, we want to do this for our other elements as well, but again, I know this video is getting a bit long, so let me just do a little copy-paste job with the video pause. And once again, with the magic of our video, I've paused it and I've populated the rest of our if test so that it will tell us if we have too much or too little carbon, whatever we have. Now what I'm going to do after this if block is complete, I'm going to show a notification that shows basically the result of all of our equations here. So I'm going to say show alert, and the alert is going to be our result message. So I will say Control C and Control V. Okay, that is a lot of work we've just done without testing it out. And I get a little bit nervous when that happens. So what I'm going to do is we're going to go ahead and try things out as simple as we can, because this is a very long block. This is something that we're going to want to think very hard about. Can we refactor this? Can we make this more efficient? So I'll go ahead and choose Save Project. And now it looks like I'm going to need to redeploy. So just a moment. Looks like I might have killed it. Just a moment. We'll be right back. Now take a look at what happens in the emulator. I've hit Show New and water appears. Now nothing is in the box. I'm going to choose Guess. And what's it going to say? You don't have enough oxygen. Carbon are correct. You don't have enough hydrogen. So nothing's in the box. There is no carbon in water, so carbons are correct because there are no carbons in water. Hydrogen and oxygens are not correct because I have nothing in the box. So I'm going to go ahead and bring my oxygen into the box. That's going to add 1 to my oxygen. I'm going to grab a hydrogen, put that in the box as well. Okay, there's our hydrogen. Let's add 1 more hydrogen and carefully put it in the box, making sure that we don't collide it with the carbon. Now I have 2 hydrogens and an oxygen. Let's hit Guess again. Oxygens are correct, carbon are correct, hydrogen are correct. So see, now we have all of the elements that make up water. What I'm going to do now is I'm going to go ahead and drag these back out. We know there's a kind of a mechanical way that we can do this, but I'm going to drag them out. Then it's important that I choose Clear. So that will refresh our in-memory list. As a matter of fact, when I hit Show New, I should have it go ahead and clear that in-memory list. Let me hit Show New again until we get carbon dioxide. So there's carbon dioxide. Again, with it clear, with nothing in the box, let me go ahead and hit Guess, and it should tell me my carbons and my oxygens are not correct. Maybe they're too low. And it should tell me that my hydrogens are correct because there's no hydrogen in carbon dioxide. So I choose Guess, and what do we get? You don't have enough oxygen, you don't have enough carbon, hydrogen are correct. Okay, let's take 1 carbon and put it in. Carbon added. Let's take 1 oxygen and put it in. Okay, oxygen added. Now that's carbon monoxide, not dioxide. Let's go ahead and hit Guess and see what we get. Oxygens are correct. You don't have enough carbon. Hydrogen are correct. Let me bring in 1 more carbon. Okay, carbon added. Now let me choose Guess. Oxygens are correct. Carbon are correct. Hydrogen are correct. Okay, now I could clear and show new. Remember, I could also still make my own elements if I wanted. I could go ahead and clear these guys out. Okay, I'm going to go ahead and move them out. And then I'm going to choose clear. Okay, that looks good, cleared. So now let's make some carbon monoxide. So that's carbon and oxygen. And, you know, we kind of have a two-way street here. We can add molecules. We can also carbon monoxide. We can add molecules, and so I'm going to go ahead and choose Save. Okay. Save it to our tiny DB. Go ahead and move my elements out just a minute. I'm going to go ahead and choose Done for this. Okay. So the existing functionality still works. So move my elements out, hit Clear to clear out our memory. And now I'm going to show new until I see carbon monoxide. Let's see if we can get that to work. Okay, there's our carbon monoxide. Let's go ahead and hit Guess. You don't have enough oxygen, you don't have enough carbon. Hydrogens are correct. So let me move in an oxygen and a carbon. This should be a correct answer. Let's go ahead and choose Guess. Oxygens are correct, carbon are correct. But you know what we haven't tested? What if we put too many in? Let's put in another carbon to make this carbon dioxide. And now choose guess. It should tell us we have too many. Oxygens are correct. You've added too much carbon. Hydrogens are correct. Okay, so our game works on a simple scale. What I would do if this were a real game, carbon monoxide, carbon dioxide, oxygen, atmospheric oxygen, hydrogen peroxide, water, these are all very common elements. Sorry, common molecules. Now, how many molecules are there in the world? Who knows? It's an infinite list. What I would do to take this one step further as a real game is I would allow people to make new compounds, new molecules, and hit save. But the difference is instead of just saving to TinyDB, I would save to a cloud-based database, and then I would have all applications sync with that. What I'm doing then is instead of me going through all the effort of entering all this data, I'm sourcing it to the community. So the community, people studying, professors, professional chemists, PhDs, things like that, as they discover new molecules, they can put them in here and save them, and then that is quizzable for anyone else who uses the app. Maybe we could rate them based on complexity. Say water and hydrogen peroxide, those are all easy. But then when we get to things like ethane and benzene and other things like that, those are things that maybe are a more difficult level where we have things like carbon rings and things like that. So we could possibly group and classify them. But at the moment, I think we have a very functional but simple and drag and drop kind of game. I think it's a lot of fun. So thanks for sticking with me through the video series. I'm sure we'll have more where we'll expand on this, and I look forward to seeing you then. Thank you.